So we only have Sanish, right? Or is there anyone else who is missing? Anyone? It's just Sanish, right, team?
I think there is one more student in the group, but we don't know his name.
Okay, fine. So I think let's start with business statistics. So I don't know if you are all aware whether business statistics is different from the regular stats that we use or the elementary stats. I'll tell you about what exactly is business statistics. So it takes the data analysis tools from elementary statistics and applies them to business. So, for example, estimating the probability of a defect coming off a factory line or seeing where sales are headed in the future. So, many of the tools used in business statistics are built on ones that you have probably already come across. So you may have come across in your basic math, such as mean, median, mode, or a bar graph or bell curve, and basic probability. So, hypothesis testing, if you may know, where you where you test out an idea, and when the regression analysis is there, where fitting data to an equation, they are all built on this foundation of business statistics. So basically, this particular presentation is going to be practically identical to an elementary statistics, and the whole module that we have discussed will focus on elementary statistics. So there will be slight difference when I say elementary statistics and business statistics. So question the questions will have, say, a business feel, as opposed to questions about medicine, social sciences, or other non-business subjects. So data samples will likely be business oriented, and some subjects usually found in a basic stats course, like say multiple regression, um, it might be downplayed or maybe omitted entirely in favor of more analysis of business data. So with that, let me share my screen. Let me know if my screen is visible. Is it?
Visible.
Okay. So statistics for business analytics. As I said, there are so many things you guys must already be aware of. So there's nothing new about analytics that you may study now. It's just that the focus will be on business more, or the questions will be more business oriented. Okay. Okay. So what exactly is statistics? Let's start with that. It is a methodology for collecting, analyzing, interpreting, and drawing conclusions from information. Here I have taken this example where, say, suppose this is a data where women are going to get water, and there is this person who's an informer. This informer collects the data that women travel miles to get the water and gives this data to panchayat of that village from where this particular group of women they belong. So this panchayat will analyze, interpret, and then draw conclusions from that particular information received from the informer, and will draw a conclusion or inference and will reach out to a decision or result. So this group is a sample, and they represent all females of that particular village. So that will be our population. All females of that village is population. This group of female is sample. So let us go to a better definition of statistics. So as Agreste and Finlay mentioned in 1997, that statistics consists of a body of methods for collecting and analyzing data. So statistics is more than tabulation or computation of numbers and graphical representation of these tabulated numbers. So it involves analysis and interpretation of such numbers and giving logical meaning to that data. Okay, and we can break statistics into three components: design, description, and inference. So design would mean that planning and carrying out research studies, whereas description would mean summarizing and exploring the data. Inference means making predictions and generalizing about the phenomena represented by the data. Okay, so statistics is the science of studying or dealing with uncertain phenomenon or events. It is more of the methodology of collecting samples or data through survey. So for example, say if we collect or make a survey where we say that we want to know whether people believe in aliens or superheroes more. So that could be one survey. Similarly, we can also go for, say, to predict or to analyze whether this pandemic will adversely affect the careers of Generation Z. Okay. So these could be the methods of collecting the data. So we have two important concepts of statistics, which are population and sample. So population is the collection of all individuals or items under consideration in a statistical study. And sample, as Wiz in 1999 mentioned, that it is that part of the population from which information is collected. So we have population and we have sample. So to understand it better, we have this very famous grand picture of statistics. So this is population, which will have all the variables or the elements, and some randomly picked data will form sample. So mostly, only few features or traits of an object or individual is considered for drawing conclusion during research at the same time. And this observation emphasizes the importance of something called set of measurement. And so this set of measurement was actually it was the whole definition of population and sample was based on this set of measurement, and an entirely different definition was given by Johnson and Bhattacharya in 92. And it said that a statistical population is the set of measurements or records of some qualitative trait corresponding to the entire collection of units for which inferences are to be made. Similarly, for sample, they said that a sample from statistical population is the set of measurements that are actually collected in the course of investigation. With this, there emerged two types of population. So one is finite, the other is hypothetical. So as the name suggests, finite population means that population that could be physically listed, or it is important to calculate the items or individuals under observation. So, for example, total population in all the flats of a society or total number of students in a school, we can calculate that because that is finite, that is countable. But for hypothetical population, it is that population which is uncertain or future based on a previous or present event, such as if the sales report is to be predicted for future, the data could be collected from the past record. So to understand the sales that was in the year 2020, in the year 2022, to understand or to predict that data, we can actually understand it through the past report, that is of year 2020 or 2021. So that will be hypothetical population. Now, branches of statistics. So there are two branches of statistics. One is descriptive, the other is inferential. So all these things are very basic, but then they are very important for problems that we will face in future. So descriptive statistics means it is that branch of statistics that involves organizing, displaying, and describing data. So suppose, and before I go on to the example of descriptive, let's understand inferential. It is that branch of statistics that would involve drawing conclusion from a population which is based on information contained in a sample taken from that particular population. So there will always be conclusion or inference drawn by using sample of data. This sample is our data, and based on this sample, we draw conclusion for our population. Okay, so about descriptive statistics, see, as you could see here, you collect data. That collected data is organized, analyzed, and displayed. But the major difference between the two is that this particular data is not sure whether it is the sample that is part of population or is population the entire population. So we at this stage do not really know. But in inferential, we do know that the data that we have is just the sample of a particular population. So in this descriptive statistics, we have data which is received, then organized. So it could be organized in any order, and then it is analyzed. This organized data could, or the data that is so collected could be structured data or unstructured. So moving ahead to analysis. So during analysis, we do not draw conclusions based on any sample of population. So we do general analysis of the data using graphs or visualization tools. And then that data is displayed. So we explain and display data for better understanding of the data, especially for the clients. So for inferential, there will always be sample and population. We draw conclusions to predict the outcome based on the probability. So these are the two major differences between descriptive and inferential. And this is important for us, to remember the difference, because in future when we deal with data, we should be able to understand whether it is a descriptive or inferential stats that we will have to apply. Okay, so with that, I think, yes. So I'll end the presentation. Okay, so everything that we discussed so far was something that was known to you already. I'm pretty sure you must have all studied. You are all from maths background and you know it already. But it was just a quick revision that I wanted. We will now move ahead with parameter and population, then parameter and sample. With that, there will be about the graphs. So we will discuss every graph, and then we'll just try to solve some questions of data interpretation. And then we'll move on to probability. So we'll have permutation, combination, and probability, and that is how we'll start with the stats. Okay.